Well, hello and welcome to the Bumper to Bumper podcast. I am Dave Riccio here along with John Riggle, and together we are helping you with your car, putting you in the know. We want you to know some common buzzwords, so you feel comfortable when you go to the auto shop. A lot of people like when they go to the auto shop. I think they hear this, like Charlie Brown's teacher, want
Oh, yeah.
$2,000.
Oh,
And
yeah.
and people say, I don't know anything about cars. When I talk to him on the phone, and I say, I don't either. But yeah, so just so you, because I think people are afraid I'm being taken advantage of at the auto shop, and I think I think there's some overzealous recommendations in the auto repair business. I think some of that goes on, and so people want to know the difference between what do I really need versus what's the fluff.
Yeah.
And here in our business, we do a lot of car fixing.
Yeah.
So they're broken. So it's not a whole bunch of maintenance and you got to flush this and flush that and all that stuff. We got
Yeah.
people coming in with broken cars.
Yeah.
So that's something that we see. So we want to put you in the know, common terms, so it sounds familiar, doesn't sound like it's totally out of left field. Because people call me up and they say, oh, this shop told me this, that, and the other. Isn't that crazy? And I go, no, it's not.
Yeah.
But it's a surprise to them.
Yeah.
Because they don't know what normal is. And so anyway, so I'm going to put you in the know with that. And one thing that came up the other day, we had a vehicle here, John, and it was in here for they brought it in for a transmission problem, which we took care of.
Mm-hmm.
And we put some motor mounts in it and serviced the transmission and did all that kind of stuff. And they weren't crazy about how everything felt, a week later. So they brought it back to us, and you immediately dove into it. We were dealing with their transmission ahead of time. Now, they weren't happy with the way the engine was running.
Yeah.
And what is the first thing that you looked at when you plugged into that thing?
Well, on this particular, and I can't remember if this one had codes in it. I can't remember if it had codes in it. I think it did. I think it had a couple of rich codes in it. I think that was the complaint, was they had a check engine light on it, is what it was. And I looked at the fuel trims.
Okay, fuel trims.
Yeah, which is one of the first things I go to when we're looking for engine performance issues, okay? So the fuel trims are an indicator to me how well the fuel delivery system is working,
Mm-hmm.
okay? So we kind of got to walk back and define, fuel trims, what they are, because it's an indicator for me. It tells me how much adjustment the computer is making to compensate for in-use deterioration and wear. That's basically what it is.
But it is for you, it's a quick indicator. If you're going to go there, it's a quick indicator. I mean, the first thing you do when you go to the ER is check your pulse, your blood pressure, and your temperature right off the bat, because that's going to tell them some stuff like, do we need to race this guy in, or can this guy sit in the lobby for 4 hours?
Right.
Right. And so you're going to fuel trims, and you said it's an indicator, but it's adjusting or it's compensating. So you always talk about, I love the word stoichiometric, right?
Mhm.
That's a word which is like the perfect combustion that the computer is always trying to arrive at.
Mhm.
So we have the right mixture of air and we got the right mixture of fuel, and that all comes and makes a perfect explosion while everything is used each time that cylinder fires.
Exactly. Yep.
So the computer is often compensating. So what is a fuel trim, and what is the perfect number in a fuel trim?
Okay, so yeah, we have to be careful with this because it's all over the place. Fuel trims, you won't see fuel trims. There's nothing on the car you can look at. So it's all part of the data in the scan tool that we look at. So ideally, when we build the car, if everything was perfect coming off the assembly line and going out the door, our fuel trims would always be at zero. Or
Okay.
close to zero. There's reasons why they vary and stuff. There's exceptions to everything we're going to say in this conversation. There's
Yep.
always an exception.
Always an
Just that
exception.
somebody did something else, for one reason or another. But in general, fuel trims, if we know the amount of air going through the engine, which we can calculate using an air mass meter, or we can use speed density, we can measure manifold pressure and temperature. If I know the cubic inch displacement of the engine, I know the speed of the engine, then all I really need to do is determine the load on the engine to figure out how much fuel or how much fuel injector pulse width to use to get our mixture as close to stoich as possible. So I can get real close just using the inputs that we have and a little bit of knowledge that we have about
Mm-hmm.
the way the thing works. So ideally, we would set the injector pulse width at a base injector pulse width value.
Mm-hmm.
For whatever RPM or load that engine is under, we can pick that number. We can get real close. We can get really, really close to delivering the right amount of fuel for the amount of air going through the engine. So if we did that right, everything would come up at zero.
Everything would come up at zero.
Yeah.
And you mentioned codes, and we'll hit this more in another episode, but there's no code for fuel trim.
Well, there is.
Is there?
There is. Yeah, there is, right? See? PO 171, 174. Those
Okay.
are the two
Oh,
most. Yeah. And those are the right in the top 10 codes. Those are the two most common codes that you get is fuel trim or the evap codes are like
Right.
way high. And the reason we see that is because that was mandated as part of OBD2 when OBD2 was first structured. The engineers knew how important those fuel trims were. So the fuel trim codes were important. And that's where most people's exposure to fuel trim codes is from. They got a check engine light on. Maybe they got a car that hesitates, stumbles a little bit. They go to the auto parts store. They pull up these codes, PO 171, 174, fuel system 2 lean, bank 1 or bank 2. And they see these codes, and the first thing they want to do is put oxygen sensors in it because
Right.
that's the first component.
Yeah.
And the problem with that is there's circuit codes and there's system codes.
Uh-huh.
Fuel trim codes are system codes. Anything that causes the fuel delivery to be incorrect sets those codes.
Yeah, and I was thinking more of your lean codes, your rich codes, and that it may not say specifically fuel trim, but those are things
That's actually the global definition is fuel trim, but we'll see these worded other ways on
Sure.
the enhanced side. So yeah, so you'll see that, and that's people's exposure to it. Now, everything's dynamic. Everything is changing all the time while we're driving the car. So we do
Right.
have a little bit of tolerance. We allow plus or minus 10% from zero before we start to get concerned. All
Right.
right. There's a little bit of gray area there, probably 15 to or that 10 to 20%.
Mm-hmm.
Yeah, we got to be real careful working in there. Generally over 10, we're going to start paying attention. Most of the codes for fuel trims set when we get out to about 20, 25%.
Mm-hmm.
Okay, that's what the
Okay.
code set threshold is. So there's a little bit of gray area there. But if we're looking at fuel trims and I'm seeing, 8, 9, I'm
Right.
good with it. I'm done looking at fuel delivery. We've delivered the right amount of fuel for this thing.
So in the perfect world and perfect circumstances, you're at zero, right? But we know that not everything is perfect, so then we got to compensate. So the engine or the computer is analyzing the airflow, it's analyzing the exhaust, what it looks like, it's analyzing all these things to make adjustments. Now there's long-term fuel trims and there's short-term fuel trims. So help me understand that.
Okay, so if we have, let's say we've got a car with a restricted fuel filter. We're driving it along, and we're delivering our base fuel calculation for our base fuel injector pulse width. We've delivered that much fuel. Now we looked at the O2 sensor. The O2 sensor voltage may be low, and so we're like, we need to add some more fuel. So we'll add, just a couple of tenths of a millisecond of more injector pulse width. We'll bring the fuel up. If that fuel trim still stays low, we go a little bit further. We go a little bit, and this happens quickly. This is pretty rapid fire. And so what we're doing now is we're making short-term changes. We're adding additional injector pulse width short-term in response to what the O2 sensor is doing to get our trims or get our fuel delivery back where we want. So if we have to do this and we see a trend over a short period of time where we have to keep adding this fuel, now we're going to say, well, this thing has a tendency to be lean. We're going to make a long-term change. So we're going to take whatever amount we had in short-term, we're going to plug it in and say, okay, this is long-term fuel trim. We're going to add this 0.2 of a...
It's a new baseline.
Yeah, it's a new baseline that got moved up. And we still have our short-term fuel trim is still active. It's still doing short-term changes, but now we plugged in this long-term change. So we can continue to kind of stack these numbers up, and long-term is exactly what it says. This is a long-term adjustment that we've made to the fuel delivery because we've seen this tendency. And in some respects, long-term is a little more informative to me because short-term is changing quickly all the time. And other things get reflected in short-term. Say you go into a diesel fuel cut. If you look at short-term may become fixed. It may reflect that lack of fuel. It may go high. So there's times when it's not responding just to the O2 sensor. It's responding to some other portion of the program. That's why we have to be careful using fuel trims. Like I said, I've done 8-hour classes on
fuel trim. We could talk about it all day.
Yeah, it's all over the place. And I mean, there's a lot of things. Not everybody uses the same terminology. Nissan uses air fuel alpha, and it's scaled differently. It's not scaled in percentage. It's deviations from an ideal of 1.
I'm just thinking for a consumer, trying to the terminology is different shop to shop, even technician to service writer, they may use a different terminology.
Oh, yeah.
And so I could see why there would be so much confusion
amongst
consumers when, they're trying to figure out, they're trying to understand it, and which I totally get. And the one thing I say for consumers, probably the best thing you can do is be working with a good shop, because you may not know all this stuff, and you may not retain all this stuff. If you're working with a good shop, you feel they're competent. Competent is a big thing. Competent is not universal in this business.
No.
I think more people buy things they don't need in an auto shop because they're not working with competent people. I do find like a lot of people want to do the right thing and all that stuff. So sometimes it's just knowledge base.
I think there's less absolute dishonesty in the industry than there is just a lack of absolute competence.
Competence is more of a problem.
Competence is more of a problem. Being tooled, knowledgeable, having the kind of intimate familiarity with the car that you need to have to be really successful doing these.
Yeah, you do.
These late
Yeah,
ones,
for sure you do. So I could see the confusion. So again, like coming back to terms, fuel trims is something that you may hear come up. You may hear the service writer or the technician say, "Oh, your fuel trims are high." And so if they're plus, we're adding fuel. Am I get this right? If they're minus, we're taking away fuel. So it's just an indicator somewhat of the health of the motor and the combustion process.
Yeah, the combustion process, but mainly focused on the fuel delivery.
So this one that we brought up, we were talking about in the direction we were going with that one was a leaky high injector fuel pump.
Yeah. So when we see those codes, so rich codes are probably a little less common than the lean codes. The lean codes are probably more common. The rich codes a little bit less so. But in the case of rich codes, when I have these codes where we're taking fuel away because we've got too much fuel, I got to start thinking about where does that extra fuel come from? Why do we have too much fuel going through this? So are all of our inputs correct? Is my mass airflow sensor reading correctly? My MAP sensor, manifold absolute pressure, are all these sensor inputs right to start with? So that's one of the things I do is I glance and I see what are the values here, what do they look like here? And then the other thing I have to consider is there any other place for raw fuel to come from? And there's several places. So we have an evap purge solenoid, which draws fuel vapor into the engine or allows fuel vapor that's stored in the charcoal canister to be drawn into the engine and reburnt. So that valve is pretty precisely controlling the amount of vapor we're pulling in there. If those fail stuck open, we wind up with these rich codes. So that's one of the first things I do is I unplug the purge valve, put my thumb over the end and see if it's leaking. If it's leaking, you'll feel it suck your finger in there. So that's the quick, easy test. So I rule that out. Again, I looked at my other stuff, and then I got to thinking about it for a second. And I'm like, I wonder if it's coming through the crankcase, so through the PCV system. So we can have fuel injectors can leak from the nozzle themselves, also cause rich conditions. If we get a fuel injector that's not completely shutting off, and we're getting drops of fuel that are uncontrolled or unmetered fuel going into the combustion chamber, we could wind up with the same thing. But the other thing we have on some of these late models, the direct injected cars, we've got these mechanical pumps that are driven usually off of the camshaft, these piston style pumps. If that pump starts to fail and it leaks fuel into the crankcase of the engine where the engine oil is supposed to be, not where fuel is supposed to be. So the crankcase has to be ventilated. We can't ventilate a crankcase to the atmosphere. We ventilate the crankcase through the intake manifold.
We plumb it right back into the inlet.
Right,
of the
so
engine.
we burn it. We don't want, because there always will be a little fuel drop out,
blow by.
Blow by, past the rings and stuff. And so we'll always have a little bit of that, but we can't have that go out into the atmosphere. So we use the PCV system to draw it back. So one of the tests that I do, I look at my fuel trims. My fuel trims are way negative on this thing. They're like 25, 30% negative. I'm like, that's a lot of fuel. So I disconnect the crankcase breathers, plug off all the tubes. I pull the PCV valve out of the crankcase, block all those passages. Boom, my fuel trims come right back to where they're supposed to be.
And all that fuel's
Pull
coming
the
from the
dipstick
crankcase.
out. In this case, I couldn't smell the fuel in it. A lot of times you can smell the fuel, and the other trick we'll do is we'll try to light the oil on fire. You can't light oil with a lighter. It takes a lot. But if you swing that lighter past that dipstick and it goes off on you, there's too much fuel in the
oil
crankcase. And indeed, in this case, I'm pretty sure that was what was happening. We were doing this for somebody else or something. They were going to go fix it or something. I don't remember. We didn't follow this one through, but I'm 99% sure that's what was wrong with that car.
All right. Well, that's fuel trims, a little bit of a rough idea how they work. A lot of stuff we talk about, it's broad brush, but we're trying to get the concept to you so you understand it, and then it'll sound familiar when you're talking to somebody about it. Because if you own a car for any length of time, it will come up. So thanks for joining us. We'll see you next time on the Bumper to Bumper podcast. Well, hello, I'm Dave Riccio, your host of the Bumper to Bumper podcast, and I would like to thank you for tuning in. If you want one of your car questions to be answered on our podcast, tap the link in the description for a chance to have your question featured. And while you are there, we would love for you to like and subscribe to see more Bumper to Bumper podcasts in the future.